In this tutorial, we're going to identify the horizontal asymptote of rational functions. So I have here a rational function where we can change the degree of the numerator and the denominator. So first, let us change the degree of the numerator and the denominator so that the numerator has a degree less than that of the denominator. So if I choose to put 2 for A, then I can put 3 for B, or 4, or 5. And this satisfies the condition stated here. The degree of the numerator is less than the degree of the denominator. So let's take a look at the graph. Now we're looking for the horizontal asymptote. That means we are looking at the far right and the far left. We don't care about what's happening here around near zero or near zero. We want to see what's happening at the far left and right. So we notice that the function flattened out as we go to the left and right. And if we trace the graph going to the left, the value of y is close to 0. So we say that the horizontal asymptote is y equals 0. On the right side, it's also y equals 0. Okay, so when the degree of the numerator is less than the degree of the denominator, we claim that the horizontal asymptote is y equals 0, or the x-axis. Now let's try other scenarios. Let's make the numerator have a denominator, have a exponent of 3 or a degree of 3. Still, the horizontal asymptote is at 0. If I make this equal to 4, still less than the denominator, than that of the denominator, the horizontal asymptote is still y equals 0. Okay, so now what happens if we want to make the degrees the same? Change the degree of the numerator and denominator so that the numerator has the same degree as the denominator. So let's do that. So right now the denominator has a degree of 5. If I make the numerator have a degree of 5 also, then they have the same degree. Does this graph have horizontal asymptote? Since the graph flattens out on the far right and far left, then this graph has a horizontal asymptote. So let's take a look at what this number is. So if you look at the y value stays at 3. Actually, the graph is getting closer and closer to 3 as we go farther and farther to the left. And it does the same thing as we go farther and farther to the right. So in this case, the horizontal asymptote is at y equals 3. Okay, so what else will impact the horizontal asymptote? What if I change the leading coefficient? Let's say I make this 12. Let's take a look at the horizontal asymptote. Now the horizontal asymptote is at 6. What if I make the denominator 3? What is the impact in the horizontal asymptote? If I look at the value of y, now it is at 4. So we notice that the horizontal asymptote is the quotient of the leading coefficient of the numerator divided by the leading coefficient of the denominator. And this happens when the degrees of the numerator and denominator are the same. Okay, so now let's move on to the third scenario. Change the degrees of the numerator and denominator so that the numerator has a degree greater than that of the denominator. And let's see what happens. So let's just make the 5 here 6. Look at the graph. Does the graph flatten out on the far left and the far right? It doesn't. Therefore, there is no horizontal asymptote. So we say here that the graph does not have a horizontal asymptote. So I hope that now we can tell just by looking at the features of the equation whether the rational function has a horizontal asymptote or not. And if it does have a horizontal asymptote, whether the horizontal asymptote is the x-axis or it is somewhere else.